So hey nerds, this is Suman and this is our today's integral, right? So this looks very much beautiful. So how to tackle this? So you can actually do your own methods. You don't have to follow my method. I would like to firstly say that because you have to be independent, right? So after some time, sometimes after following me or some others people, you might be independent and you are able to do how to calculate integral. So firstly, let me just do this. So it would be, I do not have to explain about this thing, right? So I get I is integral dx square root of x square plus a square, and this is x squared plus a square, right? So I am going to make a substitution here. So I would like to substitute, put x squared plus a squared is t squared, such that x is going to be my square root of t squared minus a squared. So why should I have to substitute here? Because I know in later case I would have to put the value of x such that I had used that term. So now we have to do something interesting here. That is, let's differentiate because we want dx in terms of some dt. So it is going to be 2x dx, and the integration of this would be, differentiation would be 0, and it is 2t dt. So x dx can be written as 2t dt, t dt, right? So this would be our thing. So I have to write dx is t dt over x, and x is square root of t squared minus a squared. So my integral is going to look like integral. In terms of dx, I have to write this much, t dt over t squared minus a squared into. In terms of square root of this, I have to put t squared by, in terms of x squared plus a squared, this is t squared. It makes sense. Okay, so I is going to be integral, and let's see here. This will cancel out. We get t squared dt by t squared under root t squared minus a squared, right? So this is going to cancel out, and we got I is integral dt over t squared minus, square root of t squared minus a squared. So once it has come, because the sign has changed and the variable has changed, and I can actually make a good substitution here of sec theta. So put our t is a sec theta. So dt can be written as a sec theta into tan theta d theta, right? So our integral is going to be integral. So in terms of dt, we have a secant of theta tangent of theta d theta whole over square under root of, in terms of t square, we have a squared sec squared theta minus a squared, and if you pull out integral sec theta tan theta d theta whole divided by, so if you take a squared as common and take it is out from the square root, you get a over here, and it is going to be under root sec squared theta minus 1. So it is going to be, the secant square theta minus 1 is nothing but integral sec theta tan theta d theta over under root of tangent of square theta. So the square root term will cancel out, and the tan will cancel out the another tan. So we get simply I is integral sec theta d theta, and this is the same problem that we had solved in our earlier videos. So this is going to be ln sec theta plus tan theta with some constant c, right? So I is going to be ln, in terms of sec theta, I can write t over a, and in terms of tan theta you can write under root of, or simply square root of sec square theta minus 1. So the sec is this much, and sec square is going to be t squared over a squared, right? And this is minus 1 and some constant c, and I is going to be ln t over a plus. And this way, if you take this out common, you get square root of t squared minus a squared, and if you pull out the a square term from the square root, you get a plus some constant c. So I hope up to there this would be an easier task. So I is going to be ln. So the t is our another variable written in terms of x, right? So if you want to just take t here, you have to put square root over here. So this is going to be x squared plus a squared square root over a plus square root of, in terms of t squared, so now you have to put the value of t squared as x squared plus a squared minus a squared over a with some constant c, right? So I'm going to erase it, and I got my I is ln. So what I am left here is this is going to cancel out, and the square term is going to come out from the bracket, and it is going to be x over a plus under root of x squared plus a squared, and this is a plus c. So up to there, this is the final result, but we don't want a in our formula, so we have to use another property of logarithm, that is log of a over b can be written as log of a minus log of b. So now we have to separate this. How are we going to separate this? Like the 2a are both common in each side, so we can just make it like simply a, right? And we have to use the property that is I is equal to ln x plus under root x square plus a square minus log of a plus some constant c. So a is our constant, and if you put a constant in a logarithm, you will again get some another constant. So this is going to be our ln x plus under root x squared plus a squared plus, and this is the constant, and if you add another constant with constant, you will end up getting another constant c, or let us simply say this is going to be c dash. Therefore our integral dx over, what is our integral, that is x squared plus a squared, can be written as ln x plus under root x squared plus a square with some constant c. So this would be our final result. So up to there, bye bye, and try to send your problems.